Welcome to our last week of lectures. Week 10, I won't have any new materials. It'll just be review. So this is it. These are the last really topic that we're going to be looking at. So this week, we're going to look at how do we use integration to find how long a curve is in the plane. So we're going to look at finding the arc length of a function f of x. The setup is something like this. We're going to start by taking a function f of x. I'm trying not to do anything specific, but we want to still be able to picture it. So I'm using an actual graph. We're going to split the interval over which we want to know how long it is into equal size pieces. So we split this into n pieces. And then for each one of these, we're going to start, A is going to be labeled as x sub 0. Then we're going to have the next one is going to be x sub 1, x sub 2, etc., all the way to B, which will be x sub n. So there's going to be n plus 1 many labels that we use, but there's only n many intervals. If we look at the ith interval, let's zoom in over here. It's going to look something like this. So here we have our x-axis. Above the x-axis, we have whatever it is the function does. This here is going to be x sub I minus 1, and this will be x sub I. So this length right here, we're just going to label as delta x. Over on the y-axis, we're going to have f of x sub I, which will be y sub I. And over here, we're going to have, f of x sub I minus 1 and y sub I minus 1. And over here, we're going to have the image of f of x sub I, which will be y sub I. And so this change here, we're going to write as delta y. This one actually is not constant, so I'm going to call this delta yi. The delta x's are constant. They're always the same. Now, the basic idea from our picture is this. We're going to put marks on the graph over each one of these points that we're making, and then we're going to play a straight line, connect the dot. And then we're going to use this straight line connect the dots as an approximation for how long the whole curve is. So on this interval, when I'm connecting from here to here, my green straight line looks like this, and it's pretty close to the true curve. And if I draw this right angle triangle right here, you'll notice that this length on my triangle is delta x, and this height is the change in y, delta yi. So my green length, according to the Pythagorean theorem, this green length, which I'm going to call length I, it's just going to be the square root of delta x squared plus delta yi squared. This will give me the line segment from the image of x sub I minus 1 to the image of x sub I. And then when we're putting up the whole approximation for the length of our curve, the whole length will then be approximated by the sum, where I goes from 1 to n, of the square root of delta x squared plus delta yi squared. That's just going to be the approximation. Now, because we have a delta x squared here, it'd be nice to pull it out, and it's going to actually be super, super useful. So if I factor this out and I divide out from delta yi, I get the following. This becomes the sum. I goes from 1 to n. Of what comes out of the square root is delta x. And inside the square root, I get 1 plus delta yi over delta x all being squared. And that's because when I pull out a square here, I also have to pull it out from here, which means it ends up dividing the delta yi squared. And since both of them are being squared, I can pull the square completely out. Now, this here actually is a Riemann sum because we have the change in x that comes outside, and we're just adding a bunch of these components. So we can take the limit, and we can get L is exactly the limit as n goes to infinity, if I call this L sub n, of the ln's. And when we pass to the limit, this discrete sum becomes an integral. It's the integral from a to b. The delta x becomes the dx. And inside, we get the square root of 1 plus, well, this becomes the change in y over the change in x. That's dy dx. That's f prime. So we get f prime of x, and we still have the square here, so we have to square it. And this is the formula for how long the graph of f is going to be as x goes from a to b. So you can find this formula in the book. They go through all these pictures and they rederive it, but this is the basic principle. So the next video, we're going to use this formula to compute a couple different arc lengths, and then you'll be able to practice on your own. That is it for now. See you in the next video.